Hi everyone, this is Athira, and today we're going to be exploring a technique for solving quadratic equations known as completing the square. This method will allow us to rewrite any quadratic equation in a form that's easier to work with. So first off, what is completing the square? Completing the square is a method where we take a quadratic expression such as x squared plus bx and turn it into a perfect square trinomial. Why do we do this? Because a perfect square trinomial is easy to factor, and from there we can solve quadratic equations. So there are a couple steps to complete the square, and the steps are pretty easy to follow. And so if you have a quadratic equation or a quadratic expression such as x squared plus bx here, we follow these 3 steps to complete the square. So the first one would be to find half of the coefficient of x. Find half of the coefficient of x. And the coefficient that we're talking about is this b right here. That is the coefficient of x. And so half of the coefficient of x would just be b over 2. The second thing that you do is that you square that number that you get. So that would be b over 2 squared. And the third step would be to add the squared value to the expression to create a perfect square trinomial. So add squared value to create a perfect square trinomial. So for example, if the number that you get, let's call this squared number here, let's call that c, your resulting equation would be x squared plus bx plus c. So let's take an example. Let's take, for example, x squared plus 8x, and we want to complete the square for x squared plus 8x. The first thing that you're going to do is you find half of the coefficient. So half of the coefficient would just be this 8 here divided by 2. So 8 divided by 2 equals 4. The second thing that you do is you're going to square this number here, 4. 4 squared is 16. Then we add 16 to the expression. So your resulting expression would just be x squared plus 8x plus 16. Now this expression can be rewritten as x plus 4 squared. And if you use the FOIL method and multiply it out, you will get x squared plus 8x plus 16. Okay, so let's take another example. Let's do x squared plus 5x, or let's do 6x. So the first thing that you're going to do is you're going to take half of b, which is the b value right here, is just 6. So you're going to take 6 divided by 2, which is 3. And the second thing that you're going to do is you're going to square 3. So 3 squared is 9. And your resulting expression after completing the square, after you add 9 to the expression, would just be x squared plus 6x plus 9. And this is the same as x plus 3 squared. And you get the 3 value from here when you divide b by 2. Okay, now that we know how to complete the square, we can use it to solve quadratics. So let's start with an equation. Let's take x squared minus 10x plus 7 equals 0. The first thing that you're going to want to do is subtract 7 from both sides in order to move this 7 to the other side. So we're going to take minus 7, and this will equal x squared minus 10x equals negative 7. The second thing that you want to do is you want to complete the square on the left side. So you're going to take, once again, you're going to take half of the coefficient of x. The coefficient of x right here is negative 10. So you're going to take half of negative 10, which is negative 5. And then you're going to square it. So negative 5 squared is 25. So now we've completed the square, and we can add 25 to the left-hand side of this equation. So your resulting equation would be x squared minus 10x plus 25 equals negative 7. And now here, you're going to want to add 25 to both sides, because you can't add 25 to one side and not add 25 to the other. So this right here is going to be your resulting equation. Now we can go ahead and simplify. X squared minus 10x plus 25 can be rewritten as x minus 5 squared, and negative 7 plus 25 is just 18. The next thing that you want to do is you're going to take the square root of both sides. So if you take the square root of both sides here, you're going to get x minus 5 equals plus or minus the square root of 18. And now, to isolate x, you can add 5 to both sides. So if we add 5 here and add 5 here, you just get x equals 5 plus or minus the square root of 18. And the square root of 18 can be rewritten as 3 root 2, because the square root of 18 is just equal to the square root of 9 times the square root of 2. And the square root of 9 is 3, so this is equal to 3 root 2. And so x equals 5 plus or minus 3 root 2. And that's the solution to your quadratic equation. Let's go through one more example here. Let's take let's take 2x squared plus 12x plus 16 equals 0. Now the first thing that I'm going to do is I want this coefficient right here to be 1. And luckily I can do that by dividing this whole left-hand side, or dividing the whole equation by 2. So if you divide this by 2, you'll get x squared plus 6x plus 8 equals 0, because 0 divided by 2 is still 0. Now, just like in the last problem, the first thing that I'm going to do is move this 8 here to the other side. And the way that I do that is that I can subtract 8 from both sides. So if I subtract 8 from both sides, we get x squared plus 6x equals negative 8. Now we can start completing the square. So the first thing to do to complete the square is that you take this b value divided by 2, so half of the coefficient of x, and 6 divided by 2 is 3, and then you square that value. So 3 squared is 9. So we can add 9 to this left-hand side of the equation in order to make a perfect square trinomial. And now whatever you do to the left side, you also have to do to the right side. So we have to add 9 on both sides. And now we can rewrite x squared plus 6x plus 9 as x plus 3 squared. And that equals 2, 1. The next thing that I'm going to do is I'm going to take the square root of both sides. So let's take the square root on both sides. And this is going to be equal to x plus 3 equals, the square root of 1 is just plus or minus 1. And now you can subtract 3 on both sides in order to isolate x. So we get, if we subtract 3 on both sides, we'll get x equals negative 3 plus or minus 1. So x, if you add 1 to negative 3, x could be negative 2. And if you subtract 1 from negative 3, x could also be negative 4. So those are your two solutions. Okay. So the next thing that we're going to do is we're going to write quadratic functions in vertex form. So what is vertex form? So you have your standard form of a quadratic equation. So your standard form is going to be ax squared plus bx plus c, which we usually see. We usually see quadratic equations in standard form. Vertex form is y equals a times x minus h squared plus k, where h comma k is the vertex. And when I say vertex, I mean the vertex of the parabola. So every quadratic equation is going to look like that U-shaped curve, which is called a parabola. And h comma k is going to give you the vertex of that parabola. So how can we write quadratic functions in vertex form? So let's take an example. Y equals x squared minus 12x plus 18. We want to write this quadratic equation in vertex form. So it's currently in its standard form. So the first thing that we're going to do is we're going to start by completing the square on this, on x squared minus 12x. So x squared minus 12x plus whatever we get plus 18. So the first thing that we're going to do is divide this negative 12 here by 2, because we're going to take half the coefficient of x, and that's going to be negative 6. And then we want to square that number, and negative 6 squared is just 36. So now we know what goes in the question mark. It's just 36. And now we want to remember that in order to balance the equation, we also have to subtract 36 on this side, because if we just add 36 and we don't balance it, it's going to change the equation entirely. So now we can rewrite this x squared minus 12x plus 36 as x minus 6 squared, and 18 minus 36 is just negative 18. And now you have this equation in vertex form. And your vertex is going to be at 6, comma, negative 18. Because as we see in the vertex form, hk is going to be the vertex, and in the equation that we have, h is 6 and k is negative 18. So that's why we can look at this equation and see that the vertex is going to be at 6, negative 18. Okay, so we're going to do one last example here of writing an equation in vertex form. So let's take the equation y equals x squared plus 10x plus 16. So the first thing that we're going to do is we're going to take this term, x squared plus 10x, and complete the square. So in order to do that, you take half of the coefficient of x. The coefficient of x is just 10 here, the 10 here. And taking half of that, you would get 10 over 2 is 5. And then you're going to square that term. So 5 squared is 25. So now you can add 25 to this here in order to create a perfect squared trinomial. But we also want to subtract 25 outside of the parentheses in order to balance the equation. Now x squared plus 10x plus 25 can be rewritten as x plus 5 squared. And then 16 minus 25 is just negative 9. So this is already in vertex form. And to find the vertex, you just look at these two terms, which if you remember the form of the equation, this would be your h value and this would be your k value right here. And so the h value would be negative 5 because in the form of the equation, y is equal to a times x minus h squared. And since this term here is positive, we know that the x value for the vertex is negative, and the k value is just negative 9. So this here would be your vertex.